So good evening, all of you.
Good evening, sir.
Good evening, sir.
Good evening, good evening. So in last lecture, we have introduced about the vectors, and then we were discussing about the coordinate system. And the first coordinate system was Cartesian coordinate system. And we talked about what is the Cartesian coordinate system, what are the unit vectors, how to represent a vector in this coordinate system, what is position vector, and then we were discussing about what is DL vector, infinitesimal displacement vector, DL. So if you are at any point P whose coordinates are x, y, z, and if you change x, y, z by elemental change in x, y, z, dx, dy, dz, you will move to point Q. Then position vector changes from R to R plus DL. So this changes infinitesimal displacement vector. And that is given by, that is expressed as dx x cap, dy y cap, dz z cap. Is it clear?
Yes, sir.
And you can visualize that dl vector if you draw an elemental cube about point P. So let's see this elemental cube about point P whose coordinate is x, y, z. So change x by dx, y by dy, z by z, dz. So you will move to point Q along R cap. So this diagonal length dl, this will represent the dl vector. So now you can see from this figure, in component form, dl will be dx x cap, dy y cap, dz z cap. Is it clear?
Yes, sir.
Yes, sir.
So if you know dl vector, you have to remember dl vector, and then you have to visualize this elemental cube. And then you should write volume element and area element. Now see, because this is an elemental cube, so if you write volume of the elemental cube, that will be the volume element. Let's see what will be volume element in Cartesian coordinate. This will be volume element. And this is represented by d tau. So volume element is volume of this elemental cube. So because sides are dx, dy, dz, so if you multiply it, you will get dx, dy, dz. Is it correct? ठीक है?
Yes, sir.
Okay. So now you know dl vector. You also know volume element. Now we have to see how to write area element. So let's see next slide. We will see area element. Area element. So you will encounter two types of surface. Area element you have to write on the surface. So we have two types of surface. One is called as closed surface, and another one is open surface. So what is closed surface? How you will identify that a surface is closed? So whenever you have any volume, so volume is always surrounded by a closed surface. For example, if you have a cubical volume, so you will see it is surrounded by 6 surface. So any volume is surrounded by closed surface. So how you will identify closed surface? any volume is surrounded by closed surface. By closed surface. Open surface, any open surface is surrounded by closed lines. If you have an open surface, that will be surrounded by closed line. For example, let's see if you have a let's take first example is closed surface. Closed surface. Consider a cube of side A. It's a cubical volume. It's a cubical volume. This is X cap. This is Y cap. And this is Z cap. This will be the origin. This is the origin O. And the sides are A. Sides of the cube are A. So it's a cubical volume. And this is surrounded by 6 surface. Let's say this is surface 1. Opposite you have surface 2. Let's say this is surface 1. Surface 1 is that is perpendicular to x-axis. Opposite to this you have surface 2. Then this is surface 3. Y is equal to A plane. Opposite to this surface 4. This is surface 5. And this is surface 6. Yes or no? Is it correct?
Yes, sir.
Now we have to write area element on each surface. Let's see area element on each surface. Area element on each surface. So surface 1. If you draw an elemental area over this surface, this is elemental area. So this is, what will be this length? This will be dy and this will be dz. So surface 1 is x is equal to A plane because this plane is perpendicular to x-axis. This particular plane is perpendicular to x-axis. So for this plane, x will be always fixed. Yes or no?
Yes, sir.
Now, when you have a closed surface, what will be direction of dA? dA is perpendicular to the surface pointing outward. So this is the outward direction. This is the direction of dA. So on a closed surface, direction of dA is perpendicular to the surface, pointing outwards. So this direction is outward. So what will be dA over this surface? Just see. Magnitude will be dy dz and direction will be x cap. Is it correct? Now in
Yes.
same way, because this is the origin, so opposite to this, you have this particular plane. What will be fixed for this plane? Can you tell?
X equals to 0.
Yes, because this is the origin. So if this is x is equal to a and this is the origin, so this will be x is equal to 0 plane. So second plane is x is equal to 0. And then on this surface, let us first show the direction on each surface. On surface 2, perpendicular to the surface pointing outward. So this direction is minus x cap. On surface 3, perpendicular to the surface pointing outward. This is y cap. Surface 4, perpendicular to the surface pointing outward. Surface 5, perpendicular to the surface pointing outward. Surface 6, perpendicular to the surface pointing outward. So you know direction and magnitude, you know, because when x is fixed, variable will be same, dy dz. So this is minus dy dz x cap. In same way, you can write on other surface also. Surface 3 is y is equal to a plane. dA is dx dz y cap. Fourth is y is equal to 0. And dA is minus dx dz y cap. Surface 5 is this surface z is equal to a. Z is fixed. So what will be variable over this surface? X and y. So this is dx, dy. Direction will be z cap. Surface 6th. This surface z is equal to 0. So dA will be minus dx dy z cap. So in this way, you can write the direction of area element on a closed surface. dA will be always perpendicular to the surface pointing outward. So you have to remember how to write the direction of dA, and magnitude you can see. Because in area element, you have two variables. Is it clear?
Yes, sir.
Yes, sir.
Now you have second one is open surface. Open surface. So how you will identify open surface? As I have told you, any open surface is surrounded by closed line. So let's see. This is x cap. This is y cap and this is z cap. And consider this particular surface. And in this case, this closed line will be given. It's like a rectangular surface. So that will be surrounded by closed line. It's a thin sheet. So thin sheet is a open surface because there is no volume here. So that's why it is surrounded by closed line. And in whenever an open surface is given, they will specify you the direction of closed line. It may be clockwise, it may be anti-clockwise. Is it clear? That any open surface is surrounded by closed line. You can always identify the closed line that surrounds the open surface. ठीक है? Now again area element. And what will be this side? This is dy and this side is dz. So magnitude, you know, you have to see direction because magnitude is dy dz. But what will be direction? Let's see. What will be direction here?
Sir, X cap.
X cap.
So again you have to use right hand rule. Now see, second time I'm using right hand rule, and this is for direction of dA. This is for direction of dA. So again, use your right hand and move your fingers in the direction of closed line. Use your right hand and move your fingers in the direction of closed line. Then thumb will give you direction of dA. So in this case, direction of dA will be x cap. ठीक है? So dA will be given by dy dz, and this direction is x cap. This is according to right hand rule. Use your right hand, move your fingers in the direction of closed line. Then thumb will give you direction of dA. Then let's say if this direction is clockwise. So when it is clockwise, if you will write the dA vector, so magnitude will be dy and this will be dz. So use your right hand and move your fingers. Use your right hand, move your fingers in the direction of integration. So thumb will give you direction of dA. So this direction is minus x cap. ठीक है? Is it clear?
Yes, sir.
So now dA will be minus dy dz and x cap. So in this way you can write area element whether it is closed surface or open surface. Whenever you have open surface, you have to use right hand rule. So second time I am using right hand rule. In first case, we have discussed the direction of cross product of two vector using right hand rule. But this is the direction of dA on an open surface. Is it clear?
Yes. Yes,
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 sir.
sir.
So now you know how to write dl, dA, d tau. We will use dl, dA, d tau when you have to calculate line integral, surface integral and volume integral. So I am writing this in Cartesian coordinate. You will see we will same thing we will write in a spherical symmetry. Then we have to write in cylindrical symmetry. Only then you can calculate line integral, surface integral and volume integral in different coordinate system. ठीक है? So any doubt up to this point?
No, sir.
So can I take next slide?
Yes,
Yes.
sir.
Now let's see. You can write dot product and cross product of unit vectors. Dot and
Excuse me, sir.
yes,
Sir, can you show me the last slide, please?
yes.
Done, sir.
Okay. Now see, dot product and cross product of unit vectors. Unit vectors. So you know that in Cartesian coordinate system, we have three mutually perpendicular axes, x cap, y cap, and z cap. So, and they are perpendicular to each other. So what is x dot x? y dot y and z dot z. This value is 1. And what is x dot y, y dot z, z dot x? This will be 0.
Yes, sir.
X and x angle is 0. So that value is 1. And this will be 0. Now you can find what will be x cap cross y cap. So direction of x cap cross y cap. So use right hand rule and move your fingers from x cap to y cap. This will give you z cap. Similarly, y cap cross z cap. This will give you x cap. Z cap cross x cap. That will give you y cap. If you see y cap cross z cap, that will be minus z cap. So that is right hand rule. X cap y cap is z cap. And then y cap cross z cap is y cap cross z cap is x cap. And z cap cross x cap is y cap. And you can remember this if you move in the anti-clockwise direction. So if this is x cap, let's say this is y cap, this will be z cap. So just to remember it, so x cap cross y cap is z cap, y cap cross z cap is x cap, z cap cross x cap is y cap. But if you move in opposite direction, you will get minus sign. So x cap cross z cap is minus y cap, or y cap cross x cap is minus z cap. Is it clear? So if you move in this in anti-clockwise, you will get positive sign. If you move in clockwise direction, you will get negative sign. So this is dot product and cross product of unit vectors. Is it clear? And you can also see what will be x cap cross x cap. This is 0. Y cap cross y cap is 0. Z cap cross z cap is 0. Clear?
Yes, sir.
So that is all about Cartesian coordinate system. How to represent a vector, position vector, what is dl, dA, d tau, and cross dot product and cross product of unit vectors. Is it clear?
Yes, sir.
Yes, sir.
Now we will define the triple product. Let's define the triple product. So because if you take cross product of two vectors is a vector. So again you can take dot product and cross product. So that is we can define a scalar triple product. Let's define a scalar triple product. A scalar triple product. So scalar triple product is, let's say you have you have first taken cross product of B and C. So scalar triple product is A dot B cross C. And how to calculate it? You will see this A dot B cross C is, you have to remember it. And this is also CAB. Sometimes you have to use this result that A dot B cross C is B dot C cross A, and that is C dot A cross B. So you can remember this rule as this is ABC, BCA, CAB. Just for remember, you can take it as in this order ABC, BCA, and CAB. Is it clear?
Yes, sir.
And how to calculate it? This is given by A dot B cross C. If you write it in component form, you have to find this determinant value. Just write the value here: AX, AY, and AZ. You have BX, BY, BZ, and you have CX, CY, CZ. If this is given in component form, so how to find the numerical value? That, and this will be a sum, a scalar value. Scalar triple product is a scalar value, and that scalar value is given by expanding this determinant. Is it clear?
Yes, sir.
So how to expand it? AX. So this is BYCZ minus BZCY. Then I am taking with minus sign, minus AY. So this is BXCZ minus BZCX, and then plus AZ. This will be given by BXCY minus BYCX. So you can easily expand A dot B cross C to get the numerical value. Is it clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Now, if you see, what will be magnitude of A dot B cross C? What will be A dot B cross C? So this will give you volume of a parallelopipe
Actually,
yes,
sir, ये last term में AZ into BXCY
yes, BXCY minus BYCX. BXCY minus BYCX. Yes. How you will get? Just delete this and then cross multiply. So this is BX, na? Yes. This is BXCY. Please correct it. So this is BXCY. Is it correct now?
Yes, sir.
ठीक है?
Yes,
Okay. So A dot B cross C is the volume of a parallelopipe generated by A, B, and C. So let's say if you have a base is A, B cross C will give you area of the parallelogram generated by B and C. And then if you take B cross C n cap will be perpendicular to this. So you have to take projection of A along n cap direction. So in general, it is A dot B cross C. Even if it's a cube, so that will give you volume of a cube. Or even if you have a parallelopipe, so just find the mod A dot B cross C, and that the sides are given by A, B, and C. Okay? Is it clear?
Yes, sir.
Yes, sir.
Sir,
So this is the
sir, what is parallelopipe?
okay. Let us redraw the parallelopipe. Let me draw it. Let us redraw here. Let's see. I am taking here. This is the base. This is B vector, or let's take it as I'm taking this to be a B vector, and this is this is a C vector. And you have a vector like this. Okay. So let's take this represents a parallelopipe. Cube is, this is the cube. So in this case, let's say this is B, this is C, and they are perpendicular. This is A. So A dot B cross C will give you volume of a cube. But here, if you take, if this is slightly tilted here, so B cross C will give you what? Direction will be n cap. Direction will be n cap. And then you have to take projection. And if this angle is theta, so this will be mod A cos theta will be projection along this. So mod B cross C is the area of the base. And if you multiply with mod A cos theta, so that will give you volume of this parallelopipe. Yes or no? Just this cube is, if it is slightly tilted, so that is the parallelopipe. Yes or no? Is it clear?
Yes.
Okay. Now
Yes,
we can
sir.
also define vector triple product. Vector triple product. So vector triple product is, you can take A cross B cross C. This defines the, so how to calculate? First find B cross C, you will get a vector and then take cross product. But there is a rule to calculate it. We call it as back cab rule. So this is B, because this will be a vector quantity. So this is B A dot C minus C A dot B. So this is called as, you can remember this formula. Normally we remember it as a back cab rule. What will be A cross B cross C? Back cab rule, because it's a vector. So BAC means B A dot C, CAB is minus CA dot B. So it's a back cab rule. Sometime you have to use these results. So that's why you must remember triple product, scalar triple product and vector triple product. Is it clear?
Yes, sir.
So that is all about Cartesian coordinate system, and you all know about Cartesian system. Now main problem is with spherical symmetry and cylindrical, especially spherical symmetry. If you can visualize the spherical symmetry, then you can easily visualize cylindrical and Cartesian. So next will be spherical symmetry. Please note down.
Sir,
Yes.
sir, here B bar is a scalar product of A bar dot C bar, or it is a vector
Which
product?
one? This is B into A dot C, because A dot C is a scalar. If you
So
multiply
B
with a
bar
scalar, it's a
is,
vector. Hmm?
sir, B bar is a vector product of A bar dot C bar, or scalar product?
Which one?
Sir, in the solution.
The B A dot C.
Yes, sir.
So A dot C is the dot product, and then you are taking a scalar product. You know, you can multiply a vector by a scalar. So this is the
Yes, sir.
rule
Yes, sir.
that A cross
Yes,
B
sir,
cross
got it.
C is equal to this value, and A dot C is a scalar. Scalar Multiply with vector is a vector quantity. So A cross B cross C is a vector quantity. This will be a vector quantity. ठीक है? Is it clear?
Yes, sir.
Okay. Now we will see let's talk about spherical polar coordinate system. This is spherical polar coordinate system. Here coordinates are r theta phi. Coordinates are r theta phi. So we have to represent same vector A in spherical symmetry. So A can be written as AR r cap, A theta theta cap, and A phi phi cap. That is how vector A is represented in spherical symmetry, where r cap, theta cap, phi cap are unit vectors. So let us first specify r theta phi and the unit vector direction. So you know that in a spherical polar coordinate system, now we have first three mutually perpendicular axes x, y, z, and in spherical symmetry any point P lies on surface of a sphere. So any point P lies on the surface of sphere. So where this r is the radius of that sphere. R is the radius of this sphere. R is the radius of this sphere. So let's draw a sphere of radius r. R is the radius of this sphere. Now what is theta? Theta is this angle. Angle made by radius vector with z axis. So I am showing this arrow shows the positive direction of theta. Theta is angle made by radius vector with z axis. Radius vector makes an angle theta with z axis, and the arrow shows the positive direction of theta. Is it clear what is r and what is theta in spherical symmetry?
Yes.
Now see, let's draw perpendicular from point P on z axis. So this angle is 90 degree. . So then you will get this plane. And this line is parallel to this line. What is projection of R along Z? Because this is the triangle. Consider this triangle. This is perpendicular. So angle between Z and R is theta. So what will be projection along Z? This projection will be R cos theta. And what will be projection in perpendicular direction? This is R sin theta. Yes or no? Is it clear?
Yes, sir.
Now you will get a plane. And this plane makes an angle phi with x-axis. This plane, dotted plane, makes, which contains r cos theta and r sin theta, that makes an angle phi with x-axis. Okay? So phi is angle made by plane. Which plane? Containing r cos theta and r sin theta. With x-axis. Okay? Is it clear? What is r, what is theta, and what is phi?
Yes, sir.
ठीक है? Now show
Yes,
the
sir.
direction of unit vector. Let's show the direction of unit vector. Let's show the direction of unit vector. Try to show the direction of unit vectors. Try to show the direction of unit vectors. Now see, by definition, unit vectors are always in the direction of increasing coordinates. So now see, r, this is the increasing direction of r. Let's show increasing direction of r is r cap. Increasing direction of theta. So that is perpendicular to r cap, but because this arrow shows the positive direction of theta. So if point P move along r cap, theta along theta cap, then theta must increase. So that's why this will be the direction of theta cap. Why? Because if this point P moves along theta cap, theta is increasing or decreasing? Pause. See the arrow. Theta is increasing. Is it
Yes,
clear?
sir.
So that's why this is the positive direct. We have to specify positive direction of r cap, theta cap, phi cap. Then you know the negative opposite direction. Because if you move in opposite direction, theta will decrease. So this is positive direction of theta cap. And what is phi cap? Phi cap is perpendicular to this plane. Because if this plane moves in the phi cap direction, phi will increase. So here if you want to show, this is phi cap. And r cap, theta cap, phi cap, they are perpendicular to each other. Is it correct? R cap, theta cap, phi cap, they are perpendicular to each other. Yes or no?
Yes.
R cap, theta cap, phi cap, they are perpendicular to each other. Is it clear? Can you visualize r, theta, phi and unit vector direction?
Yes, sir.
Now, let's see what are the possible limits of r, theta, phi. So in this symmetry, r can vary from 0 to infinity. You can take any radius. What about theta? What about theta?
0 to pi.
Yes, theta 0 to pi. What about phi? 0 to 2 pi. Yes. So why theta 0 to pi and phi is 0 to 2 pi?
सर अगर थीटा को 2 पाई ले लेते तो डबल टाइम काउंट कर लेंगे क्योंकि पाई
Now
ऑलरेडी
see, let's see. I am showing you what is the symmetry of theta. So radius vector makes, definition is what? This radius, it is angle between two lines. So let's say if this is the radius vector is here, so this angle is theta. But if radius vector is on this side, so then this will be the theta. Yes or no? Both, this is also positive theta. This is also because now radius vector is towards this side. So this will be positive theta because this is z cap. So when this point P is on this axis, what will be theta? Theta will be 0. And when this will be in xy plane, let's say this is x. Let's say this direction is x and this is y. So when point is in xy plane, point P is in the xy plane, theta will be what? Pi by 2. So if you are in xy plane, what will be theta? Theta is pi by 2. So it means from 0 to pi by 2, 0 to pi by 2, you will cover the upper hemisphere. Whether you are this side or this side, both are symmetrical. This is also positive theta, this is also positive theta. So whether you are moving from this side to this side, 0 to pi by 2, or from this side to this side, 0 to pi by 2. Same symmetry is there. And then from pi by 2 to pi, you will cover the lower hemisphere. So because of symmetry of theta, that is angle between two lines, theta varies from 0 to pi. 0 to pi by 2, you will get the upper hemisphere. You can cover the upper hemisphere. And pi by 2 to pi, you will cover the lower hemisphere. Is it clear?
Yes, sir.
सर
Yes.
सर जब थीटा माइनस वाई डायरेक्शन में होगा मतलब सेकंड क्वाड्रेंट में होगा तो हम कैसे उसे लोकेट करेंगे मतलब कैसे उसका कोऑर्डिनेट्स बताएंगे इसमें स्फेरिकल पोलर
No,
कोऑर्डिनेट्स
no,
में क्योंकि थीटा तो एक ही होगा
not.
ना
Arey bhai, you are on the surface of a sphere. Now you asked me where is the point. You are in xy plane.
यस सर
So then theta will be this direction. Because they are perpendicular. Now, if this point is here, then this will be the direction of theta cap. If point P is here, then this will be the direction of theta cap. This will be the direction of r cap. This will be the direction of r cap. Yes or no? So, because when you have a sphere at any point P radially outward direction, then theta cap is just perpendicular to it. ठीक है?
सर
Let us.
लेकिन
हाँ बोलो.
सर अगर थीटा सेम है दोनों क्वाड्रेंट में लेफ्ट और राइट मतलब फर्स्ट और सेकंड में तो
अरे भाई
अगर
कहीं हो रेडियस, इफ यू हैव अ स्फीयर at any point P, there will be r cap direction. So that at that point, just draw a tangent at that point. So that will be the direction of theta cap.
सर
You
नहीं
have either
पॉइंट
upper
कैसे हम
hemisphere.
बताएंगे उसके कोऑर्डिनेट्स कैसे बताएंगे थीटा एक ही होगा ना तो फिर वो
No, you
लेफ्ट
have
में
to
होगा
see
या
at
राइट
what point, P lies at which part of the sphere. Whether it is upper hemisphere or lower hemisphere. Accordingly, this point will just see. Theta varies from 0 to pi. So 0 to pi क्या होगा? This can be on this axis or on this axis. You can see the direction of theta. At any point you can specify theta cap direction. Is it clear?
यस सर
Sir,
Hmm.
sir, how we will account for the phi range?
Yes, let's see. Now see, if I take, let's say x cap is perpendicular to it, means outward direction is I am taking x cap. And I am taking this direction to be y cap and this direction to be z cap. So this is the x cap direction. Yes or no?
Yes, sir.
Now see, if you have any point P here, so what you will do, from origin to point P, you will draw a sphere of radius R. So let's just visualize it. This point is the origin. Origin is this point, and you have any point P here. You can see this is the origin and this is point P. So what you will do, you will connect origin with point P and you will draw a sphere of radius R, and this point P will always lies on the on the surface of its sphere. Is it clear?
Yes, sir.
Now see, what will be R cap? R cap will be away from increasing direction of R, and this direction is Z cap. So what will be theta? Theta is this direction, because this is Z and this will be the theta that I have shown you
Yes,
here.
sir.
So theta cap will be perpendicular to R cap, and that will be in the increasing direction of theta, because if point P moves in the theta cap direction, then theta will increase. Yes or no?
Yes, sir.
Yes, sir.
Now see, this angle is theta. So if you take projection of R along Z, this will be R cos theta. This is R cos theta. And this projection will be R sin theta. Just see, this line is Z axis. So this projection is R cos theta, and perpendicular direction projection is R sin theta. Yes or no?
Yes, sir.
Yes, sir.
So now this plane makes an angle phi with x-axis. Whatever I have shown you, this plane makes an angle phi with x-axis. Is it clear?
Yes, sir.
Now what will be the direction of phi cap? Because if I am assuming this to be x-axis, so it will make some angle with x-axis. Let's say this angle is x-axis. So this is r cap, theta cap. What will be phi cap? Now you can see phi cap is this direction, because r cap, theta cap, phi cap is perpendicular to both r cap, theta cap, and in the increasing direction of theta, in the increasing direction of phi. So if you move this plane in the phi cap direction, just see phi is increasing or decreasing, because this is zero angle, this is phi 0. So phi is increasing now.
Increasing. Increasing.
Phi is increasing now. So r cap, theta cap, phi cap, they are perpendicular to each other, just like x cap, y cap, z cap. And what if you can visualize here, r cap, theta cap, phi cap, it will look like this. This will be the situation. Is it clear?
Yes, sir.
Is it clear to everyone? What is
Yes,
r,
sir.
theta, phi and unit vector?
Yes. Yes, sir.
So now see the symmetry of phi. Symmetry of phi. So this is the x direction, and this is xz plane. So when this is the xz plane, what will be angle phi? Can you tell?
0 degree.
0, because this makes an angle 0 with x-axis. Now if this is a yz plane, now what will be? This is x-axis. So what will be angle between this
90.
plane and x-axis?
90 degrees.
Pi by 2.
90.
Pi
90.
by 2. Again rotate by pi by 2. So this is pi. Again rotate pi by 2. 3 pi by 2. And again rotate pi by 2. You will get same position. So means if you rotate this by 0 to 2 pi, then you will return to same position. Yes or no?
Yes, sir.
So that's why in this symmetry, because phi is the angle made by the plane with x-axis, so you have to move on the whole circumference. But what is the symmetry of theta? Radius vector makes an angle theta with z-axis. So that's why 0 to pi by 2, you will cover the upper hemisphere, and pi by 2 to pi, you will cover the lower hemisphere. That's why theta varies from 0 to pi and phi varies from 0 to 2 pi. Is it correct now?
Yes, sir.
Yes, sir.
So must visualize r, theta, phi. We will take many examples. Let us first see how we will define, and then we will take example. Through examples only you will understand how to specify r, theta, phi.
Sir,
So this is,
could you please explain once more for theta, sir?
which one?
For theta, sir, that is 0 to pi. Could you please explain once more?
Theta 0 to pi. Okay, let me
Yeah.
take, yes. Let's see, let's assume this is the z axis and there is a point P in the upper hemisphere. Upper hemisphere means small, 0 to pi by 2. So there is a one point P here. So this is z axis. This is the this is point P. This is the radius vector. So radius vector makes an angle theta with z axis. This is the angle theta.
Yes, sir.
Yes. Now this angle is theta. So if you rotate the radius vector here, angle theta is same. Whether you are seeing, because radius vector is this or this or this, all angles are theta. Just visualize a cone. All angles are theta. If this is z axis, just visualize a cone about this. So all angles are positive theta. Yes or no?
Yes, sir.
So that's why when this point P is along z axis, what will be theta? Tell.
0.
0. Now this is some angle theta. Let's say this is some angle
Yes,
theta.
sir. Yes.
If you have this radius vector, let's draw a cone. So all angles are theta. But now when this point P is in xy plane, what will be angle now? Now this radius vector is in xy plane. What will be this
90.
angle? 90. If you rotate the radius vector in xy plane, whether theta will change or not?
No, sir.
No. So it means from 0 to pi by 2, you can cover the upper hemisphere. Now you can visualize, because if you rotate the radius vector in xy plane, theta will not change. So 0 to pi by 2, you need to cover the
Upper
upper
hemisphere.
hemisphere. So in same way, pi by 2 to pi, you will cover the lower hemisphere. So
Okay,
that's
okay,
why
sir.
theta varies from 0 to pi. Is it clear now?
Okay, sir. Thank
Just remember, when you visualize theta as angle between two lines, and phi is angle between a plane with x-axis. So that's why you have to move on circumference, and theta will be 0 to pi. Is it clear to everyone?
Yes, sir.
Yes, sir.
Chalo. Now see, this r theta phi are related with xyz coordinate. Now we will see the transformation also, that this same point P in Cartesian symmetry is xyz. If we will see this point in Cartesian coordinate, that point is xyz. But you can visualize same point in spherical symmetry. So xyz and r theta phi are related. So what will be x here? Just see, because this projection is r sine theta. So again, if you see projection of r sine theta along x, what will be that projection?
R sine theta
Because
cos phi.
yes, r sine theta cos phi. So you have to remember what will be x, how it is related with r theta phi. So x is r sine theta cos phi. What will be y? In
R sine
perpendicular
theta sin phi.
direction, projection will be sine phi. Yes. And z will be, z projection we have already seen, r cos theta. So if you know r theta phi, you know x, y, z. Or sometime if x, y, z is known, you know r theta phi. So if you rearrange, what will be r? In terms of x, y, z, you have to check. If you take x square plus y square plus z square. What is theta? Theta is cos inverse z by r. And what is phi?
Tan inverse y by
Tan inverse y by x. Is it clear?
yes.
Yes, sir.
So we have introduced r theta phi, unit vectors, limits of r theta phi, and we have also seen x, y, how x, y, z are related with r theta phi, and how when x, y, z is given, that is related with r theta phi. Is it clear?
Yes, sir.
Yes or no?
Yes,
Yes,
sir.
any doubt in spherical symmetry? Because once you visualize the spherical symmetry, you can visualize cylindrical also, and Cartesian is, you know. Any doubt up to this point? Symmetry is important. ठीक है?
Yes, sir.
चलो. Now we will see.
Sir, can you show previous slide?
Yes. Check it.
Okay, sir. Clear.
Okay. Now again we have to define dl vector. So let's see infinitesimal displacement vector. Displacement vector dl. Now r cap, theta cap, phi cap are perpendicular to each other, just like x cap, y cap, z cap. They are also perpendicular. So here, if you change r theta phi by elemental change, dr theta by d theta, and then phi by d phi, what will be elemental change? dl. So this dl vector is given by, you have to see change along r cap, change along theta cap, and change along phi cap. Just like in Cartesian symmetry, if you have changed x, y, z by x plus dx, y by y plus dy, and z by z plus dz, then this dl vector is given by change along x cap is dx here. Change along y cap is dy. And change along z cap is dz. This we have already visualized. You have to see what will be change along x cap, y cap, z cap. So that will give you dl vector. In spherical polar coordinate also, we have to see this change. So let's see how we will see that change. X cap, y cap, z cap. This is point P, r theta phi. This angle is theta. This angle is theta. So, and this angle will be phi. This is r. See, this will be r cap. This will be theta cap. And this will be phi cap. Is it clear? So what will be change along r cap? You can see this change along r cap will be simply dr. So you can write this term to be dr. R, this is r. So r changes to dr. So change along r cap is simply dr. If theta changes to d theta, let's see. If this changes d theta, so what will be this change?
R d theta.
Yes, r d theta. You can redraw it. If this is theta, this is r, and this change is d theta. So angle is equal to arc by radius. This is elemental change. So this will be r d theta. Yes or no? When theta changes to d theta, what will be change along theta cap? That changes r d theta. And if phi changes to d phi, let's see. This changes d phi. So what will be change along this? Because this
R
is
phi
r
theta.
sine theta. So this will be r sine theta d phi. You can redraw this. This is phi cap. This angle is d phi, and this is r sine theta. So this change is r sine theta d phi. Is it correct? So here you will get r sine theta d phi. So this is dl vector in spherical polar coordinate. Yes or no?
Yes,
sir.
You must remember dl vector. dr r cap, r d theta theta cap, and r sin theta d phi pi cap. And you can visualize, just like here, you have visualized an elemental cube whose axis is along x cap, y cap, z cap. Now you should visualize an elemental cube around this point, but whose axis is r cap, theta cap, and phi cap direction. And their sides are what? dr, r d theta, r sin theta d phi. Yes or no? Can you just assume an elemental cube whose axis is r cap, theta cap, phi cap, but the lengths along r cap, theta cap, phi cap is different. This is dr, this is r d theta, this is r sin theta d phi. So what will be volume element? If you have to write volume element in a spherical polar coordinate system, volume element d tau will be given by, this is dr, just multiply this side, dr r d theta into r sin theta d phi, and this will be given by r square sin theta dr d theta d phi. Is it clear? This will be the volume element. Yes or no?
Yes, sir.
yes, sir.
So you have to remember these results. What is dl, dA, d tau in different coordinate system? So in spherical symmetry, I have just introduced the r theta phi unit vectors. What is dl vector and volume element? In next lecture, we will focus on area element, and we will take sphere and part of the sphere so that we can write r theta phi, and on different surface we will also write the area element. Okay? Is it clear?
Yes, sir.
So any doubt in this symmetry? Because once you visualize the spherical symmetry, life is easy. You can easily visualize other symmetry. Main thing is with spherical symmetry. Okay? Is it clear to everyone?
Yes, sir.
Yes, sir.
So we will meet you in next lecture, same time.
Yes, sir.
Okay.
Yes, sir.
Okay. Meet you tomorrow. Thank you. Thank you, everyone.
Thank you, sir.
Thank you.
Thank you. Thank you.